millimeters from the top. Okay, from the top. So from here, we need to determine our second moment of area now, right? We have to determine our second moment of area. So IZZ1. So again, because of what I've developed Talion, remember last week I show you not last week, last lecture I show you the lines. I don't need the figure. I just need to look at the table. IZZ1 is equal to 1 multiplied by 150 multiplied by 10 cube over 12 plus by the area of 1500 multiplied by 123.207, right? And then minus by 155 squared, right? So this is why the depth did not move, because this is affected by the what? By the depth, right? Right? This is affected by the depth. So the depth is held constant, right? So that's a good thing. Only the width move. So 123.207 minus 155 squared. Times by 1500 plus by 150 times by 10 power 3 divided by 12. So it's equal to 1 point. I get 1.5. Wait, I think 1, 2, 3. I did not square. Squared times by 1500. Okay. Plus by 150 times 10 power 3 divided by 12. Go on. I think I'm doing something wrong. Yeah, I'm doing something wrong over here. It's not 155, it's 5. Silly me. Because this is section 1 squared. Okay. So 123.207 minus 5 squared. So it's 20.972 times 10 to the power 6 millimeter 4, or 20.972 times 10 to the power 6 meter 4. I'm going to do IZZ2 over here because I have all the information over here. So IZZ2 is equal to 200 over 104 multiplied by 10, 290, 3 over 12, then plus by 72500 over 13 bracket 123.207 minus by 155 squared. Okay, so this will be equal to 123.207 minus 155 squared times by 72500 divided by 13 plus by 200 divided by 104 times 10 times 290 power 3 divided by 12. So it's equal to 44.722 times 10 to the power 6, or 44.722 times 10 to the power minus 6. So we can determine our IZZ now. Okay, so let's determine our IZZ. So we know that our IZZ will be equal to 20.972 times 10 to the power minus 6 plus by 44.722. 44.722 times 10 to the power minus 6. Okay, so 20 power 9 or 20.972 power minus 6 plus what? 22 power minus 6 is equal to 65.694 times 10 to the power minus 6. Okay, so let's get this diagram across. So this is meter to power 4. So then we need to find our moment, right? So our moment, so if we look at our moment, so moment about Z, this will be equal. So let me pull back our free body diagram. Okay. Let me string it down. Right. So we need this to determine our moment in Z, right? So we know that we have our by. Okay, so by. So remember we wrote twice by, right? And because they are both going in the same direction, right? This is going in a clockwise direction relative to the centroid. This will be also going to the clockwise direction. So 2by, right, plus, because it's the same direction, the centroid position is equal to 123.207. So 0.123207 multiplied by bx. Okay. So this will be equal to twice. So by, which we determine, is equal to 8.66 times 10 to the power 3 plus by 0.123207 multiplied by 5 times 10 to the power 3. Okay. So our moment 2 times by 8.66 power 3 plus by 0.123207 times 5 power 3 is equal to 17.936. We're almost done, okay? Not almost, but times 10 to the power 3 Newton meter. Okay. So let's look for the maximum stress. Okay, maximum stress of material number 1. Right? And if you look at here, the moment is going this way. So this is tensile and this is compression, right? So for material 1, it will be in the tensile regime, and we found our stress x1 due to tensile load. So stress x1 due to tensile load is equal to what? Hold on. Is equal to 706.522. Okay, so it's 706.522 times 10 to the power 3 plus. So N is 1. The moment is 17.936 times 10 to the power 3. The distance is 0.12 or 0.123207. Okay, divide by the second moment of area, which is 65.694 times 10 to the power minus 6. Okay, so this will be equal to 17.936 power 3 times 123.207.065.694 minus 6 plus 506.522 power 3 is equal to 34.345 times 10 to the power 6 Pascal. Okay, I'm going to stop here now, and I think I've gone over time. what I'll do is I'll continue this again on Tuesday, and Tuesday will be a revision. Okay, so thank you for your time, and I'll stop recording now.